Okay, voordat ek nommer 16 merk, gaan ons gou ons eie ene opmaak. Okay. So, eie som, skryf jy 'n gaatjie waar jy hom kan doen. Daar's baie plekkie agter in die boek by die eksamenvrae. Okay. We've got those two spheres, one with a charge of positive 1,4 microcoulomb and one with a charge of negative 1,8 microcoulomb. Now those two spheres are brought into contact with one another and then removed. Bereken vir my die lading op elke sfeer after they are removed from one another. So calculate the charge on each of the two spheres after they have come into contact with one another and have been removed again. Doen dit gou vinnig. Julle het al sulke gedoen. Skryf dit in jou boeke. Moenie lui wees. Start off with the formula. The final charge after the whole thing will be the charge of A plus the charge of B divided by 2. Ons het al gesê, sê nou maar ons het 3 voorwerpe gehad. Deur wat sou ons dan deel op die einde? Deel deur 3. Do you guys remember? If we had 3, then you would have divided by 3. Why? Because we are calculating an average charge. Why? Because the charge will distribute evenly between all the objects. Okay, so jy stel in, hier is die tekens belangrik. Okay, you guys see that I didn't bother with the times 10 to the power of negative 6 here, né? Want die een is microcoulomb en die ander een is microcoulomb. So as ek my antwoord neerskryf, skryf ek net neer microcoulomb. Dis so goed ek het vir jou gevra, gee vir my die som van 2 kilometer lesings, né? As ek vir jou vra, wat is 1000 km plus 2000 km? Né? Dan gaan jy mos nie neerskryf 1000 km plus 2000 km nie. Jy weet in jou kop jy is besig om te werk met kilometer. So wanneer jy by jou antwoord kom, moet jy net seker maak jou eenhede is heeltyd dieselfde. For these calculations, you do not need to bother with those conversions of the units. Jy mag hom so skryf. Okay. Niks moeilik hier nie, né? Né? Niemand huilie? Okay. For B, I want you to calculate the change in charge of the two spheres. And you can pick either sphere 1 or sphere 2 or A or B or whatever we call them. What do we use to depict change when we're talking about science? Watter symbool gebruik ons vir verandering? Ja? Julle is reg? 'n driehoekie. Onthou julle hom? This means change in charge. And when we're talking about change, we always say the final minus the initial. Yes, wat jy vra? Wat was die verandering in lading? So when we're talking about change, it's always final minus initial. Always, always, always final minus initial. Okay. What was the final charge on both of the spheres? Minus 0,2. Okay. Nee? Kyk, hulle albei het opgeëindig met 'n lading van negatief 0,2. Nee? Initial is voor die tyd. Final is na die tyd. Okay? So hier is die twee balletjies met daai lading. Wat is daai ladings? Is dit hulle final of hulle initial ladings? Dis hulle initial ladings, né? Toe kom hulle in kontak met mekaar. Toe separate hulle weer. Wat is hulle finale lading nou? Negative 0,2. Okay? So for final, you substitute negative 0,2. This minus is part of the formula. Okay. Nou ek gaan gou eers A sin doen en dan B sin doen en vir julle wys dit maak nie saak nie. Okay, so for sphere A, I'm going to substitute positive 1,4. You don't need to put that plus there, but you may. Sien julle, ek hou nog heeltyd my eenhede dieselfde. Ek het nog nêrens gemaal 10 tot die mag niksie. Okay. Now I'm going to do exactly the same thing but for sphere B. And you don't have to do both of them. I just want to show you guys that it doesn't matter which one you do. Still final minus initial. What was the final charge on sphere B? Negative 0,2. Both of them have the same final charge. So that value will be the same in both instances. This minus is part of the formula. It has to be there. What was the initial charge of sphere B? Negative 1,8. En nou kan jy gaan kyk as jy daai ene doen. Gaan jy dieselfde getal maar 'n teenoorgestelde teken kry. Why is that? Why is the number the same? Because in this action where they touch one another, there is a transfer of charge. But if this bolletjie loses 1,6, where does it go? To this bolletjie, né? So those two values have to be the same. The charge increase on the one needs to be exactly the same as the charge decrease on the other one. Stem julle saam? Do you feel like lading wat die een bolletjie verloor het? Waartoe gaan daai lading? Na die ander bolletjie toe. So met ander woorde, as ons gaan kyk na sphere A, as hy 1,6 coulomb verloor, dan beteken dit die 1,6 microcoulomb gaan sit op die ander ene. So hulle tekens gaan net verskil. But we don't have to worry about the signs because now for the next question, we throw away the signs. Okay, so there was a, well, no. Onnodig? Okay. So stem julle saam, daar het 'n oordrag van lading plaasgevind, né? There was a transfer of charge. Plusse en minusse het verander, né? A transfer of charge is made up of what? What is that charge? It is made up of electrons. Okay, ek gaan nou eers net daar stop.